Hi everyone, my name is Shahar Shammari. I'm from University of Portsmouth, PhD at the University of Portsmouth. This work is actually cooperation between us and East China University, and some of the results was provided from Mr. William Zhou. And the title of our research, crack opening displacement, crack closure and crack tip strength. First of all, for the crack closure, there is some factors, which is the upside-induced closure, roughness-induced closure, or plastic weight due to some residual compressive. Also, a primary event in the front of the crack tip, and the secondary event just wake the crack tip. For our experimental method, we use the compact tension specimen, stainless steel material, 316 low carbon. The load, we use cyclic loading, and the load ratio 0.1. For A over W 0.4, and the stress intensity factor range 22.7 MPa square root of meter. We use single cycle 10-point loading and 10-point unloading, surface strain measurement using different cycles, plane stress conditions. We use the DIC method. For the DIC method, for these parameters such as the subset size 33 by 33 micrometer, step size 8.16 micrometer, we use the average size area 10 by 10 micrometer. For the displacement map on the y direction was after correlation between the deformed image and undeformed image, and the strain map. For our tracking measurements, which indicate here the zero position here indicated the crack tip, 1 to 4 indicated the wake of the crack, 5 to 8 indicated the front of the crack. For the wake area, we calculated the COD over two different X values here at 6.8 and 30.6 micrometer from the crack plane. And for the front of the crack, we calculated the average strain value, averaged by 10.2 by 10.2, all dimensions here in micrometer. The distance between each point is 1 grain size, which is 17 micrometer. For the closure measurement, was plotted the load versus COD for the close to the crack plane and away from the crack plane, and for each point of the wake side, so 1 grain size, 2 grain size, until away from the behind the crack, 4 grain size behind the crack. And it was noticed that there is a similar result obtained if we change the X values away from the crack or close to the crack tip. And also there is, we noticed there is a knee observed at 0.37. Also, we tried different cycling and to see how the cycle affect the PO, affect the load versus the COD, and it appears there is no significant effect, but for different distance behind the crack tip. And each graphs here represent first cycle, 10th cycle, and the 20 cycles. Also, the crack opening profile was recorded here for the specimen surface. It was polished, and it was recorded that the closure here it shows here the red cross here means the instantaneous crack tip, and here is the final crack tip. So we try to record the closure at each level until we reach the full opening crack occurred only at the max, and 5%, almost 5% closure at the P-min, which is 0.37. Lower than 0.37, the resolution wasn't sufficient for measurement. For the normal strain ahead of the crack tip, at each cycle, 0.5, which is 1 grain size, 0.6, 0.7, and 0.8 ahead of the crack tip, there is some scatters here at 0.6, 7, 8, and the lowest scatter 0.5, which is the closest to the crack tip, and there is no knee observed at the strain ahead of the crack tip. Also, different experiment was done, as indicated by my colleague Tim yesterday, at Diamond to calculate the strain, to compare the strain using the DIC and using the synchrotron X-ray for different material, welded steel material, where delta K is 30 MPa, square root of meter, and the load ratio 0.1. For the X-ray diffraction, and the grid size is here 1 by 100 micrometer, and also use the average strain mapping and the bulk material 4.5 millimeter in the thickness. For the DIC we use 100 by 100 micrometer. The resolution was 0.4 micrometer per pixel. Surface, we use the surface strain mapping. For the crack opening profile, we try to use the same method that we used for the stainless steel, but the resolution wasn't good as the previous one. So we excluded 5 micrometer awake of the crack. And the closure was recorded. The closure was recorded about 10% at the P-min, and opening only at the P-max. As indicated here, the 0 here indicated the crack tip position. 1 to 6 here indicated the instantaneous crack tip position. Also, the effective area of interest on crack opening measurement was recorded. The COD versus the load for area of 10 by 10, and the COD versus the load for the area 100 by 100 for 1 grain size, 2 grain size, and 10 grain size, 20 grain size. It was noticed that opening measured at smaller area of interest, and opening not measured at the larger area of interest. As you can see here, around 0.3. Also, the comparison of the result between the X-ray diffraction and the DIC for the load versus the strain in Y direction. As you can see here, the bold one represents the DIC, and the open one represents the X-ray diffraction. For area of interest ahead of the crack tip, shows the higher normal strain obtained from the DIC surface than the bulk, and also the difference in strain is reduced away from the crack tip. My conclusion is that physical closure was observed on the specimen surface from monitoring the change of the crack profile during loading and unloading. Also, load versus COD curves shows a knee, known as indicative of crack opening, which does not appear to be affected by the location or by the location of the measurement of the cyclone. Also, the normal strain ahead of the crack tip does not appear to correlate with the COD versus load or physical closure. The surface strain measured by the DIC are higher than those of the bulk strain, although neither correlate with the need and the load versus COD curves by DIC. Thanks for your attention.